It's very interesting to talk about this topic because a lot of what we discuss in AI is about using AI for text generation, images, coding, and so on. But we don't talk as much about using AI for engineering design.
Yeah, so it depends on how you define AI. I usually incorporate both machine learning and optimization within the AI umbrella. Generative AI is also not a 2019 phenomenon or 2020 phenomenon. It has been around for decades.
Yeah.
One thing where generative AI is really helping is to create these synthetic data. We've seen a lot of startups coming up. The other thing which I find more fascinating is, so we can create designs which are better than what people were doing before. But can we create designs that are innovative?
A lot of what we know today about AI, when it's doing both image generation, video generation, and so on, is that it doesn't understand physics very well.
Instead of learning just from the best design or the final product, what if you take the trajectory that the optimization solver took and you learn from that evolution of design?
How about creating your own car? My 7-year-old would be very excited if he can, design his own car and then probably get it delivered to him in a few months. Is that something you think would happen soon?
Like anyone can design anything. So you don't need a degree in an engineering college to actually tap into your creative potential.
I'm hoping that it will inspire our audience to think about more about this very interesting field at the intersection of engineering design and AI, which is very less explored, and there are a lot of opportunities.
AI is a tool. It's just another tool. It's a hammer.
Yeah.
And it will definitely impact many aspects of manufacturing.
Hi, today I have Faez Ahmed on our show. Faez is one of the few people in the world who work at the intersection of artificial intelligence and engineering design. I met Faez more than 10 years ago at a conference at IIT Kanpur. He was this young, very talented guy, and I'm not surprised he's now a professor at MIT. And it's very interesting to talk about this topic because a lot of what we discuss in AI is about using AI for text generation, images, coding, and so on. But we don't talk as much about using AI for engineering design. And with the caveat that a lot of people say that AI doesn't understand physics, right? And then you want to use it for engineering design. So we'll have Faez demystify a lot of these things today for us. And I would also like to mention that Faez's vision is to have machines and humans work together to solve some of the hardest problems in design in the world. So Faez, welcome to the show.
Great. Nice to be here, Varun. And yeah, glad to see you after so many years.
Yes, same here. So Faez, let's talk about how AI is used in manufacturing design. And, manufacturing design is a complex process, right? And multi-step process. It starts with design and then goes into various steps of manufacturing. And then we get the end product. Just to, give a reference point to our audience, I was wondering if we start with one sector and think about design in that. If you're okay with it, what do you think about automotives as picking as a sector?
Sounds great.
Okay, good. So just to start, how would we think about designing for automotive, right? How would you think about the process? Let's say I have an idea today in my mind to design a certain kind of car. And from here, I want to go to the design of a car which is manufacturable. Can you tell our audience that what are the steps to get there?
Yeah, so if you think about how the traditional car design process happens, there is the early stage design, which is really important, where a person, let's say you are a designer and you would come up with design ideas, you would sketch some design ideas. But before doing the design sketching, you also would first understand your requirements and you would go and do some customer, like what do the customers need, right? What's the voice of the customers? And you will understand requirements, what your competitors are doing. Then you'll come up with some early stage design sketches. Once that is done, you start refining that process. You do sub-selection on certain promising ideas. And at some point, you start going from the conceptual design stage to detailed design, which means that now you want to actually make a CAD model or a 3D model.
Yeah.
Now you have to send this design to your friend who is like a CAD designer. The CAD designer would maybe CAD it up. Maybe it's the same thing. Maybe it's different. They might send it to the simulations folks who will do the CFD simulation, structural simulation, and so on. And this process goes back and forth,
Well,
because the designer doesn't know what the simulations will do and the CAD will do. And that
yeah.
takes a lot of time. And eventually, when everyone is happy, they have explored a bit, then they go to prototyping stage, and then there are other steps going to manufacturing.
Got it. No, and Faiz, this is very useful. And I think if I understand this right, it's very different from software, right? Where we have a lot of control when we are writing the software because it's going to run on a machine.
Yeah, so I think there is some similarities with the software process, and in fact, some of the new ideas in the CAD industry is to use agile and some of the
I
concepts
see.
inspired by the software industry. But the key thing which really differentiates engineering design is that there is no universal language. So
Uh-huh.
there is no, like, designing a car is very different from designing a bicycle, is very different from designing a satellite, right? And
Got it.
but everyone is going through similar stages. The data modalities change a lot. Like, even thinking about 3D models, are we
Uh,
talking about a mesh, a point cloud, a CAD model? There's this all these ways to represent the same things, all these different languages, all these different physics that is at play, and that
got it.
makes the problem much more challenging. And to add to it, there is not a lot of data, which is the
Right.
common thing which I'll talk a lot about in this interview, is that the fundamental issue with the uh, AI focus on these topics is that we are not blessed with the internet data on these topics.
Sure. Sure. And all the modern LLMs, as we know, have been powered by billions of points we get on the internet. And what you're saying is that similar kind of data is not available for, let's say, a self-supervised model uh, for engineering design, right? So,
For a lot of design and manufacturing, yes.
sure. And that's very interesting. So we'll come back a little bit to this as a little later on, seeing that, when we look at Gen AI, the modern generative AI, which has happened a lot in the last 18 months, what are the opportunities and challenges with that? But I know that you worked before Gen AI came into being in applying AI and optimization techniques to engineering design, right? And you also had some experience in Australia working in the railway sector,
Yep.
if I'm not wrong.
Yep.
So, can you tell our audience that before Gen AI came, what were some of the problems in this process which you talked about, going from a very rough design, getting the customer voice, figuring out the requirements, to going to various levels of specificity in the design, if I may, and then getting some feedback from the field on how that kind of manifests. Where was AI being used in this process before Gen AI came, and where were the big wins?
Yeah, so it depends on how you define AI. I usually incorporate both machine learning and optimization within the
Yeah,
AI umbrella. And if you think about that, I think some of the biggest wins have been in practical application of optimization methods for design and manufacturing. And that is being used a lot in many, many sectors, whether those are gradient based optimization, where you are designing aircraft wings, whether you are designing like different types of engineering products. And that has been widely used and is still the kind of most commonly used method, right?
nice.
Also, generative AI is really powerful in creating the data that we need. But I want to differentiate, like, generative AI is also not a 2019 phenomena or 2020 phenomena. It has been around for
Yeah,
decades. Like, if you think about mixture of Gaussian models, topic models, they're all generative models. What has changed is that these models have become significantly more powerful and are becoming more like a general AI model, right? Like, they understand beyond a single domain. So going back to your question, most of the progress that we have seen where models have worked very well are what I would define as narrow AI use cases.
Yeah.
So I want to predict failures for my component. I will collect a lot of data and I'll make predictions for my component, and it usually works fairly well as far as you stay within the confines of your um, problem domain. Now, what we are seeing is the possibility that you can go across problems, you can learn things which are not very well defined and which are not easily uh, written down as objective functions and constraints.
Sure. Sure. So definitely we are going from narrow AI to broad AI. But
Yeah.
I just want to go back to one of the examples you said, right? Where you said that, look, we've traditionally used AI, which within the wider umbrella of optimization, machine learning, and so on, in designing aircraft wings. Can you demystify this a little more for our audience? That what is exactly these numerical methods are doing here? What is the goal of what we want in the aircraft wing, and how does some of these techniques help?
Yeah. So most of these methods, there are two ways to approach them. Well, like imagine if you take a cross section of a wing. So that would look like an airfoil or like a
Mm.
shape which is of this
Yeah.
structure. Now, what you would do is, first of all, you need good simulation models to tell how good a specific airfoil is. So that's your CFD models or your analytical solutions and so on. And once you can quantify that, effectively what you say, I want to improve on this objective. And you do perturb your design variables. In this case, you might perturb some of the nerve surfaces and so on. And essentially, you get a new airfoil, you recalculate your performance. When you improve, you do that more. When you
Yeah.
do poorly, you avoid those areas. And that's your traditional iterative optimization. Now, what machine learning does is it says, you know what, humans don't go about starting from scratch every time they have to design an airfoil. What they do is they have seen enough airfoils that if I ask you to design a good enough airfoil, you'll almost always come up with something which looks good, right? And that's your experience speaking. So you have seen enough airfoils. Similarly, a machine learning model has seen enough airfoils, or a generative model has seen enough airfoils in a data set, and it will create things that it thinks are very close to
Mix.
optimal.
Yeah.
And then you can still do your optimization.
Understood. So just from parameter optimization, it's moving a little more towards design. Is that a right way to
It is
articulate
moving
it?
towards data driven design. Yeah.
Data-driven design. And just stay for a minute on this with me, Faiz. What do you mean by a good airfoil? What is that performance parameters?
So the goodness really varies from domain to domain. In the case of airfoils, or we were talking about automotive cars, right? In the case of cars earlier, a lot of times you want to reduce the drag it would face. So
Got it.
you want the car to be of a sleek shape or an airfoil to be a sleek shape, so that when it's moving, it has reduced fuel consumption, right? In the case of airfoil, you often have not only reduce the drag, you also want to maximize the lift because you want to go up, right?
Yeah.
So those are objectives which are often very domain dependent and very use case dependent. But we assume that there is some simulations or some human factors and so on, which tell us what is a good design. And now the goal of optimization or generative AI is to maximize that.
Understood. Fair enough. So this gives a good idea of how AI was being used in the engineering design process, and you've given us a glimpse of how Gen AI is changing it, right? So it's going from parameter optimization to probably data-driven design, right? What would be some examples, Faiz, on where this has happened and shown, great efficiencies or great productivity gains, and done something which the traditional techniques were not able to do as far as engineering design is concerned?
Yeah, so I think what generative AI is offering is a lot of times we are seeing many synthetic data generation techniques, which
Mm.
means that they are augmenting your data. Your standard supervised data driven methods are often limited by how many labels you can get. And a lot
Yeah.
of times those are expensive to achieve, or sometimes not even possible, right?
Wow.
So one thing where generative AI is really helping is to create these synthetic data. We've seen a lot of startups coming up which are talking about synthetic data for X, right? Uh, which I think is a very promising approach for the field. Apart from that, then there are specific use cases that help different aspects of the design process. So, for example, something that we have looked at or thought about and uh, is getting higher performance designs. So,
Oh,
given a design case, can you actually generate something that was not that was higher performance than the previous best optimization methods? And for specific use cases, we have shown that it actually performs significantly well when compared to the baseline models. The other thing which I find more fascinating is, so we can create designs which are better than what people were doing before, but can we create designs that are innovative?
oh,
And we have shown that this is really hard, but it's there is promise for this application with the where the machine learning or the generative AI model comes up with designs that humans had not thought about before. And
yeah,
in fact, the goal is eventually can we get generative AI models that can file patents?
yeah.
And that directly is tied to innovation and um, affects the bottom line growth of a country.
Sure, sure. Very fair. So let me understand both of these a little more. So when you were talking about fair synthetic data, again, in the context of engineering design, what is the synthetic data really, right? What is it for? Is it data on various kinds of designs and which are feasible, or what? Just can you demystify this a little bit?
Yeah, so let's take the example of we had a project going on around ship design.
Yeah,
Now, if you want CAD models of ships, it's really hard
yeah,
because they're not everyone likes to share the 3D models of their ships, and there's all sorts of issues.
yeah.
Now, we can first of all use domain knowledge and so on to create some structures of ships which are feasible, and then effectively train some of the generative models to create a lot more
Got it.
ships which look very much like real ships that exist in the world,
Got it. Because
right?
it has probably inductively learned some structure in the data and is able to put out, manifest more instances
Yeah.
from that data.
And
Got
I
it.
mean, it's we focus on engineering, but if, like think about, for example, banks. They would often train synthetic data. They would often invest in synthetic data methods because they have these Excel sheets with customers and transactions and so on, let's say, and they might want to get synthetic customers,
Yeah.
which can be used to train machine learning models and so on, right? So those
Yeah.
are customers who don't exist but have transactions which are very similar to real world data. Now, taking the same idea, like we from a design perspective, you can imagine we collaborated with a bicycle CAD company called Bike CAD, and they created these thousands of bike enthusiasts, frame builders went on their CAD software and created these 3D models of bikes, right?
Yep.
Now, those are only, say, 5,000 bicycles. Now, we have trained generative models which can learn from those and then generate new bicycles, which didn't exist before. But
Yep.
also, we have like a designer goes on the website, let's say, and they create only one part of the design. So they only say, I know the frame, auto complete this. So the
Yep.
generative model can say, if this is the design that you have, these are the wheels that will go with it. These are the saddles, and these are all
Understood.
the parts that will go with it. It can also do some form of counterfactual optimization, which means that traditionally we are very good at optimizing on the physics. I want a better safety factor. I want some like physics based optimization objective, which which is well defined in some sense. But now you
Yep.
can go and say, I want a bike which looks like this another image on bicycle I found on the internet and I clicked. or I want a bike which is a cyberpunk style. So these are your text to image and so on objectives.
Yeah.
And I want the physics. And I want all these other things which are engineering focused,
Oh,
right? So generative AI is kind of impacting different stages of the design process and helping designers create better products and more innovative products, or to even learn how to create products.
understood.
This-
And Faiz, of course, of what you're saying is very, very interesting. So I have many, many questions around it, but
Sure.
I'll say ask them in no specific order.
Yeah.
Uh, you said that look, it can auto complete a bike, and so on and so forth. And you can have design preferences, you can have optimization or parameter preferences, and so on. A lot of what we know today about AI when it's doing both image generation, video generation, and so on is that it doesn't understand physics very well, right?
Yeah.
And we see videos where it tried to create these videos of a gymnast, and the gymnast didn't look like a human at all, right? Because
Yeah.
it learned the inductive bias the model had didn't capture the physics or the anatomy of humans. So, when you're doing engineering design, this is extremely important. So, how are you making sure that the designs which AI is creating are really, are really manufacturable in the physical world?
Yeah. So, and this is the most important question that my lab is focusing on. We call it precision generative AI, which is, can the generative AI be precise in answering the questions? And it directly ties with being trustworthy and so on. And I think this is what we are looking at is several approaches of addressing this problem. Uh, I don't want to go into too many details of it, but like there are some ideas around actually thinking about, we have these optimization solvers which have been around for decades. How can we train these generative models to learn from those optimization solvers? And because optimization solvers are extremely precise, what they lack is anything beyond their objective function. So we recently had an ERIPS paper where we showed that you can, instead of learning just from the best design or the final product, what if you take the trajectory that the
Yep.
optimization solver took and you learn from that evolution of design? And that evolution, we have used optimization trajectory. You can think of iPhone 1, iPhone 2, iPhone 3. That's also some form of optimization, right? Over years.
Sure.
And you can train these generative models, and they are grounded more in reality. And
Understood.
in that case, we saw there was significant improvement in precision. There are ideas around negative data. There are ideas around lots of different ways to address this. But I agree that this is the one of the critical questions for us as a community to answer to make these models more powerful.
Great. So, Faiz, also you said that, look, I mean, one of the things is that can AI file patents, design patents, right? And related question, right? And I was talking to another person called Siddharth who's using AI to design chips, right? And I asked him this question that, hey, and he was using a chat GPT kind of LLM kind of model and creating Verilog/VHDL code out of it, right? And I said that, Siddharth, did this generate anything which you had not thought of? And he said, no, Varun, it didn't generate anything which we had not thought of because, LLMs are these mimicking machines and they mimic what we tell them to mimic, what is there already in the world. And then we got into a discussion of something which I and you have done in the life, which is, and probably you're still doing it, is evolutionary algorithms, right? And I recall like 25 years back, when I was in my undergrad, uh, the Jet Propulsion Lab at NASA was using evolutionary algorithms to generate new designs for antennas, right, which would go into the space. And this was totally different from what a human would have imagined, right? Even the look of it was like so crazy that we would have never thought about it in that way. So I think there's an interesting difference there's almost a fork where there's these two kinds of approaches of doing generative stuff, right? One where it is, you set some objectives and anything goes, and there's this huge space where algorithms go and search. And then they're the new ones which are more bounded, What do you think about it? Do you think one of these two are the winners, or the winner is a combination of these, or somewhere in between, or you don't see it as a distinction at all?
Yeah, so I do completely agree with the idea of some form of hybrid approach, and we call it generative optimization in my lab, which is optimization has its strengths, which some of the hype of generative AI is ignoring.
Mm.
Optimization is really good at precision, and it's really good at going outside the things that it has seen. But
Mm.
where optimization lacks is anything which is not well codified into parameters and objective functions. And once the dimensionality and problem becomes hard, optimization will take forever, right?
Yeah.
Generative AI is really good at that part. So why not just combine the two? And in fact, we have shown for the same problem, like if you go on my website, you have these very complex mechanisms which can write MIT or IBM and so on with a single motor. Before we worked on that project, we were not sure that it was even possible to create a very complex curve like that with a mechanism, with a single motor mechanism, right?
Mm.
But what we explored, and in some sense, that's innovation. We
Mm.
used the ideas from generative model to learn these multimodal design spaces and then augmented the optimization with it, which basically meant the optimization now takes 2 minutes instead of running it for 7 days and not giving us anything.
Got it.
uh, and the problem is unsolvable before. So this is the place where I see there is a really interesting nuance of how do you combine these strengths? How do you combine the physics and optimization with the power of generative models and these foundational models which understand the work very well, but only a little bit. Like
Yeah.
they understand parts of it very well, and then the
Yep.
physics sometimes is missing, and there's like some interesting gaps.
Sure. Fair enough. Fair enough. So it's a lot of opportunity, but a lot of challenges
Yeah.
as well, right? As we go forward. So Faiz, if we sleep today for 10 years and wake up, how do you think engineering design would have changed? And consequently, how manufacturing would have changed?
Yeah. So thinking about design and manufacturing, I think we are at a very exciting time right now because many sectors are rethinking the processes they have been using for many years, and I do think it will change a lot. Now, predictions are always risky, so I have to be a bit careful here. But one of the things I do definitely see changing is a lot more automation and a lot more customization of products. So people can create things that they want, and they can come up with things that, instead of just waiting for some designer sitting in a headquarter of a company saying these are the three things that you can pick from. So I do
Yep.
see that for many classes of products, customization will be normal, right?
Cool.
And similarly, I think acceleration, where you come up with these digital twins or you come up with parts of the processes of the engineering design process, will become really uh, accelerated, and we'll see more innovation in those processes. Uh, Ultimately, I think the goal which I see is reduce the time that we can create better products. So right now, a car going from a concept to when it's manufactured, is the cycle time is roughly 5 years. Can we
Yep.
get it down to 1 year? And I think it's definitely feasible. And when we wake up,
So got it. Got it. So Faiz, so that's very interesting, right? You said a lot of customization would be possible, and you told us this very interesting idea before that, creating your own bike, right? How
yes,
about creating your own car, right? I'm personally not that interested in cars, but I'm sure my 7-year-old would be very excited if he can, design his own car and then probably get it delivered to him in a few months. Is that something you think would happen soon?
so I think thinking on the spectrum of customization, it's in the realm of possibility. Having
So,
said that, I don't think it would be like delivered in the market by the time, right? So there are things which are like technical challenges to achieve it, and then there are challenges of like, does it make sense
yeah.
for someone to profit from it? Now, going back to the idea, cars require a lot more than just a few parts that can be 3D printed, right? There
Well,
is significant assembly and so on. And that is, I think, the key challenge. But I do see the possibility of significant customization of your own products, including cars, uh, from an existing product.
gone. So it's not something which will happen from scratch, but let's say it can be something which is a derivative of an existing product, is what you're
Yeah,
saying.
so you cannot just say like design me a car that starts flying, right?
Yeah.
Which is again, you need a lot more innovation, a lot more physics, a lot more like assembly
Yeah.
versus saying take one of these products and make it like more Star Wars focused or
Yeah.
more individual
Like,
components of those cars are something that I want, right?
yeah. So it's a customizable car. It would probably have a limited vocabulary and grammar, and within that vocabulary and grammar, you can do what you want. Super. I think that would be good enough for my son. So I hope you and your lab and your colleagues and community makes that a reality soon.
Yeah.
Uh,
And I think one of the things which I also feel very excited about is there is with these modern LLMs and foundation models, what we are seeing is renewed interest in engineering tool design.
was it?
And there is startups coming up, some from my lab, which are thinking about these tools that we use today, whether it's CAD tools, whether they are simulation tools, there are other types of tools, and they have not significantly changed since they were first written, maybe decades ago.
Yeah.
How can we use these modern tools to really reduce the barrier of entry? So you don't need a degree in an engineering college to actually tap into your creative potential, and you can use these engineering tools to create new products while you're sitting at home. And to me, that's a huge motivation because that directly ties to this idea of design democratization that
Yeah.
we,
Yeah.
like anyone can design anything. And also, it in some sense counterbalances these issues around employment, which we are thinking there is kind of two forces. One is automation. We are automating more and more things, but there is also democratization. More people can write poems on ChatGPT now. More poems, more people can do like interesting drawings. So the question is, can we get to a stage where more people can design products for
Okay.
them?
And that will be a real democratization, right? And it was interesting that you say that because when I was talking to Anant Agarwal, who founded edX, he had a very similar view that, AI is a democratizing kind of force, which will allow a lot more people to become creators of various kinds. So yeah, so no, more power to all of you who think like that and can get us there. Let me use this first to segue in the second segment, which I have here. And this is a little bit about the geopolitics of manufacturing, right? And it is a very, very important topic because of how much is happening out here, right? Across nations in this space. So let me start by asking you, right, that if you look at manufacturing and how nations think about manufacturing, it has been dramatically changing in the last few years, right? Probably a few years back, everyone was happy offshoring things, get it where they can get it reliably and in a cheap way. And that has dramatically changed with, military conflicts, trade wars, supply chain disruptions like in COVID. And we see a lot more countries, including the US and India, thinking about getting manufacturing on their own shores, making sure that there's de-risking their supply chains and so on. Do you think the generative AI has a role to play in this geopolitics as it happens? Will it help us make things more decentralized? Will it lead to more centralization? Or how do you see AI playing a role in all of this?
Yeah, so first of all, I do think I'm glad that a lot more people are thinking about design and manufacturing. If you think about like I don't have the recent stats, but something like 16% of the global GDP and 14% of employment was related to manufacturing, and in
Mhm.
US alone there were like around 12.5 million jobs that are related to manufacturing. So it's a really important sector.
Yep.
And I agree with you that some of the discussions that we have been having at MIT in the US are around what does the future of manufacturing look like, right? And how AI plays a role. So I want to highlight that AI is a tool. It's a just another tool. It's a hammer,
Yep.
and it will definitely impact many aspects of manufacturing. What we
Hmm.
are what we are seeing and thinking about is a lot of times it is reducing. It's how does it impact the bottom line, which is reducing the cost, improving the efficiency.
Yep.
Right. Having said that, if you spend time with some of the small scale manufacturers, what we often see, and this is a study, in fact, at MIT, we are starting a new initiative called New Manufacturing, and this is a common topic where it's not just the engineers, but they are all different sectors of people involved. We are really thinking, what does small scale manufacturers, uh, how do they benefit from AI or generative AI being a part of it? And what we have observed is a lot of times there is a huge gap between we are not collecting enough data. There is a lack of understanding of what AI is. So it really ties to not just using AI to help them do better automation, in incorporating more sensors and so on, but also workforce education, and that is a big part of it.
Got it. Got it. So that's interesting, right? Because that's also a lot of discussion in India, which is not only about how do you get more manufacturing on your shore and more jobs and so on, but how do you make sure that it's not only the large manufacturers which which can crowd in all the business and it can go to the small manufacturers, right? And that's one of the risks which one sees, because all the economies of scale and let's say if you're doing robotization and so on, uh, by default falls into the kitty of the large manufacturers, right?
So it makes sense, right? I think a lot of the large manufacturers are well equipped with enough sensors and enough
Yeah.
data capture capabilities and processes to deploy AI. Because
Oh,
when we are thinking about AI, I think uh, what we often see is there is the AI demo, which is like showing a proof of concept. But
yeah.
then there is the more important part is that sustainable deployment and scalable deployment of these AI methods to really make a change for long term. And the
Yeah.
second part is something which
Sure.
most people are like, they are often stuck on, like, we did this fancy demo, which is great, right? But the
Yeah.
second part really takes time and effort and to
Yeah.
incorporate into current manufacturing processes.
Yeah. No, if the world only existed on Twitter, then I think we would have been done just showing a POC, working for few use cases. But fortunately or unfortunately, I don't know, it exists beyond Twitter, right? So,
Yeah,
so I'm with you, right? The all the hard work goes in making sure that it works case after case reliably and continues
exactly.
to create that value, right? So, Faiz, again, it's a hard one, but do you see that AI can create a revolution in manufacturing like the industrial revolution created, right? Which created great efficiencies and subsequently concentration of power with a few nations, few companies, and organizations which were a part of it, and a lot were left behind. Is that something? Do you think that Gen AI and AI coming in can create such kind of efficiencies that it may change the world order uh, in manufacturing, led by probably, as you said, right? It's about cost and efficiency. Are we talking incremental here, or are we talking exponential here? And if it's exponential, then would it change how things are stacked up right now?
So, if done right, I think there is a huge potential of completely changing the way we design and manufacture products. And in fact, for many of the new graduates, I would encourage them to think about this, because what we
Mm.
are seeing is a lot of times our future, which is our new undergraduates and graduates, they are often fascinated by everything multimedia requiring
Yep.
clicks
Yep.
and less with the physical world, right? Like things that are the machines and the things that are driving some of the industry around us. And I think if you go to any of the manufacturing plant in your neighborhood, you will immediately see how much we can gain. So
Yeah.
it's kind of like an untapped area, and that is why I feel that if done right, there is a huge potential of improvement. Having said that, that if done right is really important because it's not easy and it is very difficult to just sit on your computer and write nice codes and hope that will just work. You have
Yep.
to like really spend time with the folks who have the experience and who have been working on these topics for decades and learn from them and think on how you can accelerate the processes and augment AI also for them instead of just taking AI solutions which are off the shelf and deploying them on something that you think is like trying to fit the hammer to every problem.
Yeah. Yeah. No, no, I'm with you. And, I mean, generally we say the importance of domain knowledge in being able to apply methods like this, and generally the best solutions come when you are able to combine domain knowledge with the right AI tools. And I think here the domain knowledge is even harder to kind of get a hold on because if I understand right, a lot of it is tacit. And as you were earlier saying, it's not codified that, hey, you have this kind of codified rules or even simulations and everything will work as far as you push it in, right? So as you're saying, it's even more important to go to the field and sit with people who are actually doing it
Yep.
on
Yeah,
ground.
but also the benefit is that there's just a lot of room for improvement and very few people working on it.
Exactly, right?
I
It's like,
encourage people to think about it.
no, that's a wonderful point, right? It's a tough area, but then there's a lot of gap, right?
Yeah.
Because not many people are doing it. And Faiz, do you think that's a opportunity for India, right? Because what is happening is that, as you know, that India has been a services economy for very, very long, and we have done well, reasonably well in our startup ecosystem as well, which has been mostly software. We are trying to become a manufacturing hub now. Right? So you
Yeah.
hear all of the Make in India stuff, you hear about the PLI schemes, etc., etc., etc. The way we are doing it right now, it's a lot of catch up, right? Because countries like China and the Southeast Asian tigers have figured out the supply chains, they have hyper optimized them, they have the tacit knowledge. They're almost like killing it, right? Do you think that India can have a different trajectory to become a global manufacturing hub? Given if we both agree to the assumption that if done right, design and manufacturing is going to change.
Yeah, so I do see India has a lot of advantages. And again, I'm not an expert on geopolitics. I
Yep.
do not know enough about all the countries, but in specific to India, where I have experience and I talk to folks there who are involved in these efforts, I do feel that there is a huge opportunity. And one of the advantages is there is obviously the demographic dividend, and there is advantages around cost of production. But then there is also the advantage that the AI talent pool is pretty good in India, and
Yeah.
if they are deployed to new applications, that would be useful. Having said that, I feel there is a need for more structural changes and both in terms of workforce education, like thinking about how do we uh, train people around these topics, both design and manufacturing, as well as AI, right? Even for design and manufacturing, like giving more hands-on knowledge to our new graduates is something that colleges should think about because
Sure.
that will enhance their performance later on in these sectors. There are other factors also thinking about where are we making foundational changes versus where we are like taking someone else's tool and applying it. And I think that is a factor which folks who are working on new startups or helping big companies, they should really think about like what are the unique circumstances, unique data sets. I mean, data is a huge thing. Fortunately, India has a lot of people and a lot of things happening, so you can
Yep.
collect a lot of data. But you cannot just start in the you cannot just start any time and say, oh, now I'll have all the data, right? The
Yep.
sooner you start, the better it is, and it will take time. So yeah, and then there is the computational infrastructure, training people.
Sure. So probably a distinctive advantage for India could be being at the intersection of uh, some of the things which we need for being a manufacturing hub, which is cost of labor, resources, and so on, and then having a strong computational kind of base.
And the talent.
Yeah, the talent pool. Yeah, yeah. So that's what I meant by the computational kind of base. All these software companies which we have now done for 30 years or more, right? And what you're saying is that if we are able to combine these in a constructive manner, which is not the easiest thing to do given the hardness of the domain, but if we do it and we do it early and well, then it can create a long-term advantage for India.
Agree.
Okay, great. So first, we covered a lot of ground, right? Going from understanding how AI impacts engineering design, how it was, what has changed, to hoping that we'll be able to make a personalized car, or at least in your words, a customizable car, even if not from scratch. To going into geopolitics and thinking about what India can do better. Let me switch gears and learn a little more about you. Right. And as I said in the beginning, that, I and you met at IIT Kanpur. You were an undergrad at that point of time. So how's the journey been from being an undergrad at IIT Kanpur to now having done your PhD, your postdoc, and, becoming a professor at MIT?
Yeah, so I mean, it seems like yesterday when I was at IIT Kanpur. So now I realize it's more than a decade ago.
Yeah.
It's been a fun journey. I think not everything was planned. I had a very good time at IIT Kanpur. I think it's an amazing place. I learned a lot with a lot of projects. We worked on the Boeing autonomous navigation vehicle and a bunch of other projects with my friends. It gave us kind of an early taste of what research looked like. And then, interestingly enough, I went to Western Australia. I worked for a large mining company there. I was doing large scale data driven predictions for predicting railway failures. And I think working there it's one of the most fascinating jobs from my point of view, wearing my mechanical engineering hat, since it's not every day that you see all these like heavy equipments and large trains. Like there were trains which were 2 kilometers long to weighing
Well,
36,000 tons, right? And
okay.
if there is an accident, like it causes serious damage, and you have to predict failures for this. And it was fascinating to work there and learn on some of the engineering, real world engineering aspects, and that informed a lot of my thinking about these topics. I moved to US after working for a few years there for my PhD at Maryland, and then got the MIT offer to start as a faculty around engineering design and AI, which we have been talking about. I took a year off and went for a postdoc at Northwestern, which was also fun to explore new material science and new topics around there. So yeah, that has been the journey. And now my group currently, the Decode Lab, is primarily focusing on thinking about these precision generative AI models and broadly how we can make AI create better designs for people.
Super. And Faz, what do you do other than work? Right? Are you the boring MIT faculty? I mean, I know a lot of MIT faculty are not boring, but that's how I'll frame the question. But tell us, do you only work, or there are other interests which you have? I see a piano
Yeah.
behind you. I don't know if it's yours or
Well,
someone has left it there. But love to know, what else do you do?
yeah, so right now I have two little ones, 2 year old
Oh,
and 4 year old. So I feel
wow.
like, yeah, most of my time is occupied with them. and working a lot on house projects, like small things, tinkering in the house and so on. When we are not doing that, we are often traveling as a family, and we all like road trips, which is fun, and exploring different parts of the world.
No, your hands are really full, Faiz, being at MIT as a faculty and starting out there and having a 2-year-old and a 4-year-old to take care of. So I'll pretty much take my question back after
So
you've told me that. But look, thanks so much for taking out this time. I've now understood that you are way more busier than I thought you are. So this was a very interesting conversation, and I'm hoping that it will inspire our audience to think about more about this very interesting field at the intersection of engineering design and AI, which is very less explored, and there are a lot of opportunities. So hopefully all of us will not run on creating new images and videos, but going and seeing them get manifested in actual products. So thanks so much, Faiz.
thanks a lot, Varun, and it's fascinating to talk to you, and I'm glad to see like such insightful questions and thought-provoking ideas. Thank you.
Thanks.